again, this is actually op-amp. So this entire unit, the third unit that we're doing, we can see that this is actually dedicated to op-amp. Okay, we are mostly talking only about op-amp here. So we are going to talk about multi-vibrator. So let's try to understand what is a multi-vibrator, and after that we are going to talk about the different kinds of multi-vibrator in general. Okay? So we're just going to have a very small brief of the different multi-vibrators, for example. Okay? So what is basically a multi-vibrator? Okay? It's basically nothing but we are going to devise and make an electronic circuit, okay? And it will actually have those op-amps or transistors, okay? And this multi-vibrator is basically used to kind of implement, okay, a two-state device, okay, to implement two-state devices, and this is what we are going to explain today. Like, let's say an oscillator, okay, timer, and flip flop. So flip flop is something which you're also going to study. I think some of you might have already studied this JK flip flop and all. Okay, it's basically a very important part of digital electronics. But we use actually a multivibrator to understand this. So what exactly do I mean by two states? So when you go to digital electronics, either you have a high or a low, okay, or basically a one or a zero, okay, and that is basically nothing but the two states that we are talking about. Now, in order to make a circuit where you can have on or off, okay, high or low, we can use different electronic components, okay, and they might be an oscillator, there might be a timer or a flip-flop, okay. And when we talk about oscillator, we know we can actually make an oscillator using an op-amp or a transistor and so on, okay. So that's why like this multivibrator is important. So we are still into this smooth transition of basic electronic circuit, which actually can be used to design some digital electronic circuits. Okay, so we can basically have two states, okay, and we can actually understand it different ways. Okay, so in general, if we talk about two states, okay, it can be either uh, 15 volt. Okay, it can be, let's say this is 15 volt or 5 volt. This might be considered as high, okay, and then there might be a 0 volt. So whatever signal will have will actually vary between these two states, okay. So if something is just above this, some signal, some voltage, some noise, okay, you're straight away going to get a 15 volt signal. If it's below this, you're going to get a 0 volt signal, okay? So those kind of states will exist, and we are slowly going to understand this, okay. In general, if we talk about digital electronics, we can also call them as high or low, okay. So when we say high, we are talking about, let's say, 1, and when we are talking about low, we are talking about 0, okay. So multivibrator is basically nothing but again an electronic circuit, and it can basically we have three types, okay. So before we discuss it, okay, we can actually say that there are three types of multivibrator. Okay, the first type is basically called an astable multivibrator. Astable. So if something is stable, it's stable, right? And when we write down an A, that means it is not stable. Okay, something like that. Okay, or we can say it has got a single stable state. And then we have got something which is called the bistable. Okay? So finally, so astable, there is no stable state. Bistable means there are two stable states, okay? And then we can also have something which we actually call as the multi-stable. So what we are going to do now is going to understand all three of them one by one, okay? And we're just going to take up some simple graphs to understand that, okay? So it's not complicated. This is actually one of the easier topics that you can easily remember, okay? And if I'm asking you a question on multivibrator in general, probably the question would be an objective type, okay? Might be 2 marks, or if I give a tail to a question as a descriptive one, it will be around 2 to 3 marks max. Okay? So let's talk about the astable state. Okay, so what happens usually in an astable state, we basically have an output. So whenever you are having an input, let's say it's a sine wave, okay, and let's say it's a triangle wave, and you are using a circuit to convert it into a, let's say, a square wave. Okay, so when you do that, there will be an output, and this output, what is the variation? Okay, in which state it stays for longer period will actually be determined by what kind of multivibrator we are using. Is it astable, bistable, or multistable? Okay. So to understand this, probably I can say this, that the output actually varies between two states. Okay, between two states. Okay, and please remember neither of them is stable, and that's why it is called astable. Okay, and does not remain, okay, stable, does not become stable between any of the two states. Okay, and then what happens? And continuously changes. Okay, so whatever artificial intelligence we have today, that we basically have got some kind of change in signal, and immediately as something switches off or on its own. Okay, is all dependent on how the circuits are made, and this is actually a very important part of it. Okay, so say that time for which the output, okay, remains in a state, okay, can be decided by passive components. So we know that there are passive components and active components. Okay, so we have got the passive components like R and C. There will be capacitors and inductors and resistors. Okay, they will actually decide for how long the output will basically remain in a certain state. So if we just draw a simple graph, let's say, okay, if I just draw this, okay, and let's say we are interested in getting a signal, okay, and this is the output signal. So what we have is it will be in this state for some time, and then it will go down, and then it will be here for some time, okay, and then again it will go here. So this will keep on happening, okay, and finally at the end we are going to get a square wave where the both the states that we are actually talking about, okay, the high or the low, you can say, or the zero and the one state. In both the states, the system output will remain for some time and get back to the other state, and this will keep on happening. Okay, so this is what happens usually in a multivibrator. Okay, and this is an astable multivibrator. In neither of these states, the system can remain for a long period. So that is actually an important part. So that is about your astable multivibrator. Okay, let's talk about monostable okay, multivibrator. Okay, that is again important. So let's talk about number two. Okay, so number two is monostable. Okay, or this is also called as one-shot multivibrator. Okay, so easily know why it is called a one-shot multivibrator. Multivibrator. Okay, so this is a one-shot multivibrator, and this is again, as you can understand, there is monostable. That means there is one stable state. Okay, so before we can draw the figure, probably I can just write down this sentences. One stable, okay, state. There is one stable state and one astable state. So in one state it won't stay for long. In the other stable state, which is stable, it can remain depending on what kind of circuit you have. Okay, what kind of resistors and capacitors you are basically using. Okay, so what happens is the output remains, okay, in a stable state unless triggered. Okay, output remains in a stable state. Okay, unless triggered. Okay, so I hope you understand what is triggering. So what happens in general is, let's say I have got a smoke detector. Until and unless there is a smoke, there is smoke in the environment, you are not going to hear the alarm, right? So that is basically nothing but acting as a trigger. So here also might be a change of current or change of voltage, maybe acting as a trigger depending on what kind of circuit we actually decide. Okay, and this time period, if I basically consider from here to here, it will basically be one time period. So that's t. Okay, or we can just write down time t. Okay, depends on r and c. Now what time I'm talking about? I'm talking about the time for which it will actually remain in the stable state. Okay, it will actually be decided by this. Okay, so once again we can actually draw this. Okay, I think we can actually draw two diagrams here. So I'll just do one here, show you two examples. So what happens usually is, let's say a state is more or less here, okay, and this is, let's say, the stable state. Okay, let's say this is your stable state. Okay. And at this particular point, you are basically going to apply a trigger, a change of voltage, a change of current, maybe. Okay. You're going to apply a trigger. As soon as you apply a trigger, which might not be very long, it goes to the unstable state. Okay, and it might remain in the unstable state for some time, depending on what kind of circuit you have, what kind of value was the RMC you are using, and then it will actually come back to the stable state again. Okay, so this is what is happening in this particular case. Okay, and if I just label this correctly, this is basically nothing but the trigger that we are talking about. So this is your trigger. Okay, and this is your stable state. So this is stable. So anything can be stable. It depends on what value you consider as stable. Okay? Depends on the circuit. So maybe 0 volt is considered as stable. Okay, and this particular state, which is the other one, okay, is basically considered as unstable. And maybe we can take 5 volt as unstable. Okay, and then it will again come back to the stable state. So how does it differ from astable? Astable, it's not that it will remain here for a specific longer period of time. Okay, it will be here and then come back here and then keep on happening. But here, depending on R and C, it will be in a stable state. As soon as I apply a trigger, okay, there is no question of trigger here. If we apply a trigger, it will go to the unstable state, come back again to the stable state. Okay, so this will actually keep on happening. Okay, and it will depend on what kind of circuit I am considering. Okay, maybe I can just go one more. Okay, so if I draw this. So let's say now this is stable. Depends on me, okay, what I'm considering to be stable, okay. And at this particular point, let's say I am actually applying a trigger. Let's say this is the trigger, okay. So this is my stable state. It might be at 5 volt. And then what I do is I apply a trigger here, okay. And as soon as I apply a trigger, this will actually come back to the unstable state, okay. So now at this particular case, I can consider the 0 volt is the unstable state. It will be there for some time and it will go back to the stable state. Okay. Now the question is that you might ask is that for how long it will be in the unstable state. Okay. It will be actually depending on the circuit. So this is just a basic idea. Stable, again back to stable, and so. So this time I'm considering 5 volt to be like the stable state and 0 volt to be the unstable state. Okay. So it depends on what kind of circuit you are having. Okay. So that is basically called a multi-stable, monostable, or one-shot multivibrator. Okay. So if we just look into the part here, okay, what happens usually is that this astable multivibrator, okay, it is basically used in relaxation circuit. Okay, we are going to understand what exactly is the circuit like. Okay, relaxation circuit. And relaxation circuit means the output that you are going to get is not going to be a sine wave. It might be a square wave, it might be a triangle wave, but it's not a sine wave, and that is basically called a relaxation circuit. Okay. However, if we are basically considering a monostable, okay, it is basically used in timer circuit. So in the one of the classes I did tell you about 555 timer. Okay, so that is actually used in a timer circuit. So timer circuit means that after a certain period, probably the state of the circuit will change. It will become a off state or it will come to an on state and so on. So that is basically called as a timer circuit. Okay. So this is your astable and monostable multivibrator. And the final one is basically called as the bistable multivibrator. Let's try to understand what is a bistable multivibrator. Okay. So what happens in a bistable multivibrator? Okay, multivibrator. Okay. So what happens in a bistable multivibrator? We basically have two states which are actually stable. Okay, vibrator. Okay. So we have got both states. Okay, states are stable state. So that means you can control at what state the output will remain for how long. Okay, that is basically very important. Okay, and in general, if we just take out the point, you can just write down this: the output, okay, remains in stable, okay, remains stable in, let's say, stable 2. I'll give you the state names, okay, stable 2, unless another trigger, okay, is given. So if until and unless I give a trigger, it's going to remain in that state. Okay, and this is basically used in flip flop. So if I consider something like a JK flip flop and so on, we are basically going to use this. Okay. And how do I design them? Okay, these can be designed. Okay, designed using op-amp. We can use an op-amp to design it. Okay, we can use a transistor to design it. Okay, or we can also use a 555 timer. So this basically this timer is nothing but an IC. Okay? It's an integrated circuit. Okay, it basically works on this principle of digital electronics and logic gates. Okay, so how do I exactly draw this bistable multivibrator? Okay, the output figure. Let me just draw this. Okay. So what happens in a bistable multivibrator? We have to remember that there are two stable states. Okay, let me just draw this. So here also I do have this trigger. Okay, so I will take this. Okay, and let's say this is my stable state. So this is stable, and since there are two stable states, so I'll just write them as stable 1 and stable 2. So this is stable 1. Okay, and then what happens is I am going to apply a trigger here. Okay, so when you please draw it, you draw it clearly. Okay, when I ask you an exam, please try to explain this better. So what will happen is I will trigger this, and as soon as I trigger this, this is going to be in the second stable state. Okay, so we have got the stable 2, and then maybe I can apply one more trigger. Okay, I can apply one more trigger. It will go back to stable 1. Okay, so that is what is our multivibrator is all about. Okay, so maybe here I will actually apply one more trigger. We can do it better. Okay. So once I apply the second trigger, we are going to have the second multivibrator. So this is stable 1, this is stable 2, this is back to stable 1. So if I want to switch on and off a circuit, okay, depending on certain conditions, I can use such multivibrators.